All right, let's try to compute some integrals. For the first one here, we have an inside function natural log of x. And so we can try to use u substitution with u equals ln x. And that's going to give us du equals the derivative of ln x, which we know is 1 over x times dx. And now we want to rewrite our integral in terms of u instead of x. So we replace the natural log x by u. And then we have a dx over x, right? So that all becomes du. And we just have an integral of sine u. Okay, so that, we remember, is negative cosine of u plus an arbitrary constant c. And to get our answer back in terms of x, we can replace the u by natural log of x to obtain negative cosine ln x plus c. Okay, let's try the second one. And we're going to use u substitution again. And let's see. It's not 100% clear what we should let u be, but I think what's going to work is the denominator. Okay, let's try that out and see what happens. We'll let u be 1 plus cosine squared x. And so du is the derivative of that, so it's 0, and then this is the same as cosine of x, the whole thing squared, so the outside function is the square. That means the derivative of the outside function is 2 times cosine x, and then we have to multiply by the derivative of the inside. The derivative of cosine is negative sine x. Okay, and now 2 sine x cosine x is actually one way of expressing sine of 2x. So it's one of the trig identities. And so keep the minus sign, and then the rest of it we can simplify down to sine 2x. Okay, and that's nice because that's what we have in our numerator. And we don't have a minus sign, so maybe I'll bring that over to the other side. So it's going to become a negative du. All right, so now let's rewrite our integral. The numerator with the dx gives us the negative du. Let me put the minus sign out front, and the du over here. And then we have a u in the denominator, right? So the function is just 1 over u. And we know that the antiderivative of 1 over u is, well, the best answer with the largest domain is natural log of absolute value of u plus our arbitrary constant. And finally, we want to replace the u by the x stuff. So we get negative natural log absolute value 1 plus cosine squared x plus our constant. And that's the answer. Okay, so these two examples are a little different. They both involved a natural log at some point, but in the first one, the natural log was it was the inside function of what we started with, right? So it was involved in the u substitution process, and then it came back right at the end. Whereas in this integral, we didn't have any natural logs to start off with, but when we did u substitution, we eventually ended up with the function 1 over u, and that has a natural log as its antiderivative. Okay, so the natural log showed up in a different way. So if you're assigned integral problems in this homework, you want to look for those two different possibilities. Last but not least, we have another function which doesn't, at first glance, have anything to do with natural logs. But let's think about how we do it. Okay. If we let u be the denominator, then the derivative would be 3t squared. And we do have a t squared up here, but we also have a 4. It's not clear what to do about that. So substitution might work there. Might be able to force it to work, but my first inclination actually is to just simplify this out, break it up into 2 fractions and simplify. So let's try that. We have 4 over t cubed plus t squared over t cubed. And let's write this without fractions. So 4 times t to the negative 3. And well, this, you can cancel a t squared and you have 1 over t, and that's the same thing as t to the negative 1. Okay. So you might try to use the power rule now to integrate each of these parts. And so for the first one, we want to increase the exponent by 1. And so negative 3 plus 1 is negative 2. And then divide by that new exponent. And then for this one, well, as we mentioned in class today, you can't do this one that way, right? If you raise the exponent by 1, you get 0, and then you end up dividing by 0, which gives you nonsense. So, but remember, t to the negative 1 is 1 over t. And that's exactly what we learned today, has an antiderivative of, or an integral of natural log absolute value t. So that's the answer, and maybe we can just simplify this first term a little bit. 4 over negative 2 is equal to negative 2. Maybe I'll move that power of t back to the denominator. So negative 2 over t squared plus natural log of absolute value of t plus my arbitrary constant c. And there's some examples of integrals. Hope those are helpful.